Hello everyone. Today in this session we are going to discuss about the topic planning of a computer program. The term the problem solving is used in many disciplines, sometimes with different perspectives and often with different terminologies. The problem the problem solving process starts with problem specification and ends with the correct program. The steps to follow in the problem solving process are problem definition, problem analysis, algorithm development, coding, testing and debugging, documentation and maintenance. The stages of analysis, design, programming, implementation and maintenance form the life cycle of the system. Problem definition. What is the problem definition? In the problem definition, it is going to deal with the problem efficiently. So how the problem is? What is the problem is? This step defines the problem thoroughly. Here the requirements are specified. So this step includes understanding the problem very well. The problem solver must understand problem very well to solve. Problem analysis. Problem in this step, the analyzing the problem or analysis involves identifying the following things. That is, what are all the inputs, the data that you have to work with, and the outputs, the desired results, any additional requirements on the solutions. Next one, algorithm. What is an algorithm? An algorithm is a step-by-step procedure to solve a given problem. For solving a given problem, what is the step-by-step procedure that is required to solve? That is an algorithm. The word algorithm originates from the word algorithm, which means the process of doing arithmetic with Arabic numerals. In 19th century, Arab mathematician Muhammad al-Khwarizmi, who developed the methods for solving problems, which is used specific step-by-step instruction. And the next characteristics of the algorithm. What are the characteristics of the algorithm? A well-defined algorithm should have five basic characteristics such as input, definite, effective, terminate, output. Input. What is an input? The algorithm starts with the procedural steps to accept input data. The algorithm must accept one or more data to be processed. Definite. Each operational steps or operation must be definite. That is, each and every instruction must carefully specify that what should be done. Next characteristic is effective. Each operational step can, at least in the principle, is carried out by a person using a paper and pencil in a minimum number of items. Terminate. After some minimum number of operation, algorithm must come to be an end. Output. The algorithm is written to solve the problem, therefore it must produce one or more computed results or answer called the output. Example, an algorithm to find the area of rectangle can be expressed as we can see, given the length L and the breadth B, this algorithm finds the area of rectangle REC. So what is the algorithm? Step 1 will be start, input, and step 2 will be input the values, that is read the values L comma B. L means length, B means breadth. Step 3 is calculate the area of rectangle. Area of rectangle is equals to L into B, length into breadth. Fourth step is print the area of rectangle, output REC. And the fifth step is end of the algorithm, that is stop. In the above example, we used equal symbol that represents the assignment operator. Next example is design the algorithm to find the average of four numbers. So first step is start, second step is four numbers means we need to give four input values A, B, C, D. So input A, B, C, D. Third step is calculate the average. Average is equals to a plus b plus c plus d by 4. And step 4 is equals to output average. And step 5 is equals to stop. And the next example of the algorithm is design an algorithm to calculate the simple interest. And the given the values are principal, P, rate or time t. So we know that the simple interest is equals to PTR by 100. So how to do that? The step 1 is start. Step 2 is input P, T, R. Step 3 is calculate the simple interest is equals to P into T into R by 100. And the step 4 is output simple interest. Step 5 is stop. Next algorithm is design an algorithm to find the greatest of three numbers a, b, c. So first step is start. So we have three input numbers, that is a, b, c. So step 2 is equals to input a, b, c. Step 3 is equals to assign a to large, large is equals to a. Step 4 is compare large and b. So we are going to compare if b is greater than large, then large is equals to b, and if. In the step 5, we are going to compare the same large number with the c. If c is greater than large, then large is equals to c. And if. Step 4, print the largest number, that is output large. And the step 7 is stop. Next, next algorithm is design an algorithm to find the factorial of a number n. So step 1 is start, step 2 is input n. So we have only one number as the input, we should find the factorial of the number. The third step is first initialize the value, give the value of to the factorial, fact is equals to 1. Step 4, compute the factorial by successive multiplication, that is repeat for I is equals to 1 to n. So we should repeat the loop and fact is equals to fact into I. End of the step 4 for the loop. And step 5 is print factorial of a given number, that is output fact. Step 6 is stop. Next algorithm is design an algorithm to find the Fibonacci series. So here step 1 is start, step 2 is n. Initialize the variables. First is equals to 0, second is equals to 1, term is equals to 2. And fourth step is print the first and second, because the first and second value will be default values. And the third value will be sum of first and second, that is first plus second. So then repeat while the term is less than or equals to n. Print third, first is equals to second, second is equals to third, third is equals to first plus second, term is equals to term plus 1. And the while loop and stop. So these are the few algorithms that we have to design the few algorithms. We got to know that. Next topic is what are the advantages of the algorithm? The advantages of the algorithm is first one, it is a step-by-step representation of a solution to a given problem which is very easy to understand. That is the first advantage. Second advantage is it has got a definite procedure which can be executed within a set of period of time. Third advantage is it is independent of programming language. It is not dependent upon any programming language. It is independent to that. Fourth advantage is it is easy to debug as every step has got its own logical sequence. It is very easy to debug. And the disadvantages of the algorithm is first one, it is time consuming. It will take more time to write an algorithm. An algorithm is first developed first, which is converted into flowchart, then into the computer program. Directly we can't write the programming computer program by using the algorithm. So first we need to develop that first, then convert that into flowchart, then to computer program. Analysis of the algorithm. There may be more than one approach to solve a problem. The choice of a particular algorithm depends upon the following performance analysis and measurements. So first one is space complexity and time complexity. The algorithm analysis will be measured by the space complexity and the time complexity. What is the time space complexity? The amount of memory needed by the algorithm to complete its run. In order to finish the algorithm, what is the memory it needs? That is the space complexity. Time complexity is nothing but it is the amount of time the algorithm needed to complete its run. Okay, what is the time it is needed to complete its algorithm to run? That is the space and time complexities. When we analyze an algorithm, depending upon the input data, there will be three cases. We have three cases. One is best case, average case, and worst case. Best case is nothing but, so when the number of comparison is less, then we can call it as a best case. So when the number of comparison is average, that is an average case. Worst case is nothing but when the number of comparison or the computation is n, that is too many, or if the computation is not working properly, okay, then that case will be called as a worst case. Next heading is flowchart. A flowchart is a pictorial or graphical representation of an algorithm. Once we design the algorithm, we are going to represent that in a pictorial or graphical manner. That is called as a flowchart. And the flowchart plays an important role in the programming of a problem and helpful in understanding the logic of a program. Once the flowchart is drawn, it becomes easy to write a program in any high-level language. Flowcharts are of two types. There are flowcharts are classified into two types. One is program flowcharts, system flowcharts. The program flowcharts present a diagrammatic representation of a sequence of instruction for solving a problem. It is one diagrammatic representation of the sequence of instruction for solving a problem. System flowchart that indicates the flow of data throughout a data processing system as well as the flow into and out of the system. Such flowcharts are widely used by the designers to explain a data processing system. Importance of the flowchart. The importance of the flowcharts are communication. Flowcharts are better way of communicating of the logic of the program. What is the logic of the program? That we can easily understand by the flowchart. Effective analysis. With the help of the flowchart, problem can be analyzed in more effective way. Proper documentation. Program flowchart serves as a good program documentation which is needed for various programs. Efficient coding. The flowchart acts as a guide and blueprint during the system analysis and the program development phase. Proper debugging. The flowchart helps in debugging process, that is checking the error and correcting the error. Efficient program maintenance. The maintenance of the program becomes easy with the help of the flowcharts. The symbols are the notations used in the flowcharts. So the under purpose. So this is a symbol. So what is this? This is an what is that? What is that? Is one curved circle symbol. Okay. So that is a terminal that will be used for start or stop. That's the beginning or end or the point of interruption in a program. Then we can use that symbol. So this is an one another symbol. This is that is called one palindrome syndrome. That is a symbol that is used for input and output data or information. And the rectangular symbol will be used for processing any instruction or a group of instruction which changes the program. And this one on the hexagon notation symbol is used for looping. Preparation, an instruction or group of instruction which changes the program. And rhombus symbol, this is used for decision or branching. This represents the comparison, equation or a decision that determine the alternative path to be followed. Okay, and next symbol, this is a predefined symbol, that is a group of operation not detailed in the particular set of flowcharts. Next one, circle, that is a connector, an entry form or an exit to another part of the program flowchart, and this arrow marks indicates the flow direction. This indicates the direction of the processing or the data flow. So we'll see one example. Example, design a data flowchart and an algorithm to find a area of square. And algorithm will be written like this. Start, input side, calculate the area. Area is equals to side into side, output area, and stop. So what is the flowchart for that? The flowchart will be written like this. Start, input side, area is equals to side into side, output side, stop. Like this the flowchart will be written. So we'll see the few more examples of how to write a flowchart and algorithm to find the larger of two numbers. So flowchart, the algorithm will be written start, input A and B, because we are going to compare the largest of two numbers, and we have to use some condition. If A is greater than B, then output is A, else the output is B, and if stop. How to write a flowchart for this? So start, as usual, input will be written input A comma B. In the decision, what is that symbol, we are going to compare is A greater than B. If it is true, the output A will be displayed. If it is false, output B. Then stop the program. This is the flowchart of finding the largest of two numbers. Next, write a program or design a flowchart to algorithm to find a given number is even or odd. So for that, start, input num. Here we are going to check the condition for for a number to check whether the number is even or odd. Num percentage by 2 is not equals to 0. If it is not equals to 0, then it is an odd number. Hence it is an even number. Same thing we are going to write it in the algorithm and also flowchart. Start, input num percentage by 2 is not equals to 0. If it is true, the number is odd. If it is false, the number is even. Stop it. Advantages of the flowcharts. The flowcharts provides an excellent means of communication which is very easy to understand. It has got a definite procedure which shows all the major parts of the program. It is easy to convert it into program, and it is independent of the programming language. It is not going to depend upon the any programming language. It is easy to debug as every step has its own logical sequence. The disadvantages of the flowcharts are it is time consuming. It requires the users of the number of symbols which are properly represented. The representation of the complex logic is difficult in flowchart, and the alterations and modifications can be only made by redrawing the flowcharts. Pseudocode. This is an abstract representation of a program in English statement. In pseudocode, English words and phrases are used to represent the operation. The advantages of the pseudocode is it is easy to read, easy to understand, and easy to modify. Next heading is coding or programming. What is meant by coding? What is meant by programming? The process of writing an instruction for analyzed problem in a programming language will be called as a coding. This is a process of translating the algorithm or flowchart into the syntax of the given purpose language. You must convert each step of the algorithm into one or more statements in a programming language such as C, C++, Java, etc. Testing and debugging. What is the testing? The testing is a process of checking whether the program works according to the requirement of the user. That is called testing. Debugging is nothing but it is the process of identifying and correcting the removing of the bugs, that is errors. Okay, checking and correcting the errors. There are four types of errors are there. One is syntax error, runtime errors, semantic errors, logical errors. Syntax errors. Syntax is a set of rules which should follow while creating the statement of the program. The grammatical mistakes in the statement of the programs are called syntax errors. For example, void main int a comma b, c out, enter the numbers. C in a comma b, c out a plus b. In this program, in this example, the fourth statement produces the syntax error, has the missing of the semicolon. We don't have C out a plus b, semicolon is not there. So that will give the syntax error. Runtime error. During the execution of the program, some errors may occur. Such errors are called runtime errors. Example, if the number is divided by 0, then that will lead to runtime error. Semantic error. An error which occurs due to improper use of the statement in the programming language. For example, consider an expression c is equals to a plus b that indicates the value of the variable a and b are added and assigned to the variable c. If we return a plus b is equals to c, though the value of a plus b are added, it cannot be assigned to the variable c written right of the sign. So it is a semantic error. This type of errors will be called as semantic errors. Logical error. Logical error occurs when there are mistakes in the logic of the program. Unlike other errors, logical errors are not displayed while the compiling because the compiler does not understand the logic of the program. For example, find the area of the circle. The formula to be used is area is equals to pi r square, that is 3.14 into r into r. But if we written area is equals to 3.14 into 2 into r, then it is required the output is not obtained even though the program is successfully executed. Okay, so that is why it leads to the logical error. Documentation and maintenance. Documentation is a reference material. Documentation is a reference material which explains the use and maintenance of the program. Application for which it has been written. There are two types of documentation are there. Internal documentation, external documentation. Internal documentation, this is also known as technical documentation. This is meant for programmer who may update the program code at later stages. It can be done by defining meaningful variable names, including comments in the program code, presenting the program code clearly. External documentation is nothing but the program or application is supported with additional textual information about the application. It is useful for the user, administrator or developer. Maintenance. The program maintenance means periodic review of the programs and the modifications based on the user requirement. The maintenance is a continuous task. The documentation plays an important role in the program maintenance. It helps speedy and efficient maintenance. Programming construct. A programming construct is a statement in a program. There are three basic programming constructs are there. Sequential constructs, selection constructs, iteration construct. Sequential construct. The program statements are executed one after the another in a sequence. The sequential constructs are input statement, assignment statement, output statement. The input statement, this statement is used to input values into the variable from input device. Example, input a, b, c. Assignment statement, this statement is used to store a value in a variable. In many languages, is equals to is used as the assignment operator. Example, a is equals to 10, b is equals to 5, c is equals to a plus b. These are the assignment statements. Output statement. This statement is used to display the values of the variables on the standard output device. Example, output C. Selection construct. It is also known as conditional construct. This structure helps the programmer to take the appropriate decision. There are five kinds of selections constructs are there. One is simple if else, if, nested if, multiple selection. Characteristics of a good program. Next topic is characteristics of a good program. The best program to solve a given problem is one that requires less space in the memory. It takes less execution time, it is easy to modify and it is portable. Then modification is nothing but a good program is one which allows any modifications easily whenever needed. Portability is nothing but a good program is one which can run on any different types of machines with a minimum or no change. Approaches of the problem solving. Top-down design. The top-down design involves dividing a problem into subproblems and further dividing the subproblems into smaller subproblems until it leads to subproblems that can be implemented as program statements. A tends to B, C, D, B tends to E, F, D tends to G, H, where A is the main problem, remaining are all the subproblems. The top-down approach is taken from program design. Programs can be developed easily, quickly, committing a minimum of the errors. Stepwise refinement. The process of breaking down the problem at each stage to obtain a computer solution is called stepwise refinement. Bottom-up design. A design method in which the system details are developed first, followed by the major process. This approach is called as the reverse of the top-down design. The process starts with the identification of the set of modules which are either available or to be constructed. An attempt is to be made to combine the lower level modules to form modules of higher level. Example include object-oriented programming language using C++. Programming techniques. Unstructured program. During learning stage by writing small and simple programs without planning leads to unstructured program. Procedural programming. This method allows us to combine the returning sequence of the statements into one single place. Structured program. Structured programming is a method of programming by using the following type of code structures to write program. That is sequence, selection, iteration and subroutines. Sequence is nothing but input-output assignment. Selection is nothing but if, else, if, etc. Iteration is nothing but while, do, while, for loop, etc. Subroutines is nothing but functions. Modular programming. The process of splitting the length of the complex program into number of smaller units or modules is called modularization. The programming with such a approach is called modular programming. This technique provides grouping of the procedures which are common functionality into separate modules. The advantages of the modular programming are reusability, debugging is easier, building library, portability. This is about this session. In this session, we discussed about the introduction of the problem definition, problem analysis, what is an algorithm, the characteristics of the algorithm, few examples of designing the algorithm, the advantages of the algorithm, disadvantages of the algorithm, analysis of the algorithm, flowchart, the importance of the flowcharts, the symbols or the notations used in the flowcharts, examples of the flowcharts, how to write the algorithm and the flowcharts, advantages of the flowcharts, disadvantages of the flowcharts, what is a pseudocode, what is a coding and programming, what is a testing and debugging, what is a syntax error, runtime error, semantic error, logical error, what is documentation and maintenance, internal documentation, external documentation, maintenance, programming construct, sequential construct, selection construct, what is the characteristic of a good program, what is the approaches of problem solving, and this is about this session. So thank you.